6.3 is a decently long section, so we're going to be spending a few days in 6.3. You'll be okay. We're going to make it. Today in 6.3, we're talking about simplifying square roots using the product property. Do we know what square roots are? What's the square root of 64? 8. What's the square root of 9? 3. You're asking yourself what number times itself gives you that number under the radical. Right? Perfect. A radical expression is an expression that contains a radical. It's pretty groundbreaking stuff. That probably blew your mind, didn't it, that first sentence? A radical expression is an expression that contains a radical. An expression involving a radical with index n is in simplest form when these three conditions are met. So I'd write these three conditions down. Huh? Yeah. So the first condition is no radicands have perfect nth powers as factors other than 1. So here's what that means. First off, do we all know what a perfect square is? And don't tell me the shape that has all four sides equal to each other. So what is a perfect square? It's a number that I can take the square root of and get a nice whole number. Okay? So my first perfect square is 1. Because I can take the square root of 1 and get a nice whole number of 1. What's the next perfect square? What's the square root of 2? No? I'm asking myself what number times itself gives me 2. Is 2 a perfect square? No. 4. What's the next one? Not 6. Not 8. 9. Next one. Not 8. Not 12. Not 3. 16. So I'm getting these by doing 1 squared, 2 squared, 3 squared, 4 squared. What would 5 squared give me? 25. What's the next one? 36, because 6 times 6 is 36. 7 times 7? 49. What's the next one? 64. Next one? 81. Next one? 100. And that just goes on and on and on and on, right? Does everyone understand why these are called perfect squares? Because I can take the square root of them and get a nice whole number. Everyone okay with that? So that's what this first condition is telling me. Under my radical, I can't have any perfect squares as factors other than 1. The only exception is I can have 1 under the radical. But none of my factors under the radical can be a perfect square, because that means it would be able to be simplified further. So no perfect squares under the radical. Second condition, no radicands contain fractions. What is a radicand again? What is a radicand? Speak up. Not in parentheses, but under the radical. It's the number or expression that's under the radical, right? So my radicand cannot have a fraction in it. So I can't have a fraction under the radical. Third condition for it to be in simplest form, no radicals appear in the denominator of a fraction. So if I have a fraction, I can't have a square or a radical in the denominator. As long as it meets those three conditions, my radical expression is in simplest form. Everyone got that? Now, you can use the property that's on the next slide. It's not below. It's on the next slide. To simplify radical expressions involving square roots. So the next example, or the next slide that's going to talk about the product property, is going to be the square root of 45. Are there any perfect squares that go into 45? Any of those numbers up at the top, do any of those go into 45? Are you sure? 5 is not a perfect square. These numbers right here are perfect squares. Is 5 up here? No. So which perfect square goes into 45? 9. 9 times what would give me 45? 5. Everyone agrees that I can break 45 down into 9 times 5. On the next slide, you're going to see it just written as 9 times 5. But I wanted to show you this first, that they broke it down from 45. Okay? Is 45 a perfect square? No, so I couldn't just take the square root of it right off the bat. So let's talk about the product property. In words, the square root of a product equals the product of the square roots of the factors. So if I have a product under a radical, everyone agrees that 9 times 5 is a product. It's a multiplication problem. If I have a product under a radical, I can split each factor under its own radical and multiply those together. Does everyone see how we did that? I have 9 and 5 under the radical being multiplied. So I can put 9 under its own radical, put 5 under its own radical, and still multiply. I can also do the reverse of this. If I've got a square root of 9 times the square root of 5, I can put them under the same radical and multiply. So it goes frontwards and backwards. Everyone got that? But for today, we're just going to go this way. What's the square root of 9? 3. Can I take the square root of 5 and get a nice whole number? No. Okay. First condition was you cannot have any perfect squares under the radical. Are there any perfect squares that go into 5? No. Condition 1 checked off. Condition 2, I can't have a fraction under the radical, can I? Do I have any fractions in the radical? No. Condition 2 checked off. Condition 3, I can't have a radical in the denominator. Do I have a fraction that has a radical in the denominator? No. Condition 3 checked off. Is this in simplest form now?
Yes.
Yes, it is. So when using the product property, I like to ask myself, what's the biggest perfect square that goes into the number under the radical? So in this case, it was 45. Biggest perfect square that goes into 45 was 9. So I break it down into 9 times 5. Take the square root of 9. It's in simplest form. Okay? The next method I'm about to show you is the method that most of you will probably like to use. Okay? It may seem confusing at first, but the more practice we get with it, I feel like the easier it becomes. Okay? Do we all know what a prime number is? What's a prime number?
It's a number that can't be divided by itself.
A number that only has one multiple?
Oh, a number that only has one way of multiplying it?
Yeah. So it's a number that only 1 in itself can go into, right? So 1's a prime number because only 1 in itself can go into it. 2 is a prime number because only 1 and 2 can go into 2, right? What about 3? Is 3 a prime number?
Yes.
Yeah, because only 1 and 3 can go into it. What about 4? No. What can go into 4 besides 1 and 4? 2. Is 5 a prime number?
No.
Yeah?
Yes.
Only 1 and 5 can go into it. 6? No. 2 and 3 can go into it. 7?
Yes.
Yeah. 8?
No.
No. 9?
Yes. No.
No. 10?
No.
No. 11?
Yes.
Yeah. We all understand what a prime number is. So, this next method I'm going to show you is where we break our number under the radical. We break it down into its prime factorization. Everyone knows what I mean when I say that. It's our factor trees that you guys probably saw in elementary school. Okay, so let's start. Raise your hand if you can give me two numbers that when I multiply them together, I get 45. 9 times 5. Everyone agree with that? Okay. Can I break 9 down into anything else? What times what would give me 9? 3 times 3. Is there anything I could break 5 down into besides 1 times 5? No. Because 5 is a prime number, right? So I'm just going to bring it down. Can I bring my 3's down into anything else? No. These are all prime numbers, right? So this is what I would call my prime factorization of 45. I broke 45 down into all factors that are prime numbers. 3 times 3 times 5. Everyone good with that so far? Okay. If I have a square root, what is the index of my square root? 2. If there's no number there in the index spot, it's understood to be 2. Correct? So what I'm looking for is I'm looking for groups of 2 of the same number. So pairs of numbers. Do I have any pairs of numbers in my prime factorization?
Yes.
I got a pair of what?
3s.
Got a pair of 3s. Once again, because my index is 2. If my index was 3, I'd be looking for groups of 3 of the same number. If it was a 4th root, I'd be looking for groups of 4 of the same number. Everyone see what I mean? Are there any other pairs here? No. So here's what I do using this method. If it has a pair, I pull it outside of the radical. So the 3s are a pair, so I'm going to pull a 3 outside of the radical. Are there any other pairs? No. Is there anything without a pair? 5. If it doesn't have a pair, it stays under the radical. Did I get the same answer? Yes, I did. Everyone see that? Like I said, this should hopefully make a little more sense as we do more examples. Did it at least somewhat make sense right now as we did it? You're essentially doing the same thing as the product property. It just takes a little bit longer. It looks a little different. But what's 3 times 3? So I still essentially broke it down into 9 times 5. Took the square root of 9. What's up?
So you can't have a number that's making from the square root underneath the radical.
Right. Yep. If I did have a number that I could take the square root of, I could simplify it further, so that's why it wouldn't be in simplest form. Okay? So after we break it down, we shouldn't have any numbers. Now we do need to check it after we solve it, make sure it meets all 3 conditions, because sometimes we don't pick the correct number, essentially is what I'm saying. So, can I move on? Okay. Letter A. I have the square root of 108. We're going to do both methods here. We're going to do the product property and the prime factorization method. Which one do you want to do first? Product property? Let's do the product property. So I'm going to list out my perfect squares up here. There's my perfect squares. So remember, product property, I'm asking myself, what's the biggest perfect square that goes into that number under the radical? What's the biggest perfect square that goes into 108? About 100. 100 doesn't go into 108. $64 doesn't go into 108. 49. Are we just throwing out random numbers, or do we actually think these numbers go into 108? 4, does 4 go into 108? 4 times what would give me 108? Yep. Square root of 27 times 4. So, my perfect square is 4 here. I can take the square root of that. Are there any perfect squares that go into 27 though? What? 9. So I know I have not picked the biggest perfect square. Does that make sense? I want to find the biggest perfect square that goes into 108. 9? 9 times what would give me 108? 12. 9 is a perfect square. Are there any perfect squares that go into 12?
No.
Yeah, so I still haven't found the biggest perfect square. 16? 16 times what would give me 108?
It'd be 36.
36? 36 times what would give me 108?
3.
3? Let's try it. Okay, 36 is a perfect square. 36 times 3 is 108, right? Are there any perfect squares that go into 3? Nope. Ding, ding, ding. There's my biggest perfect square. Does everyone see how we did that?
Yeah.
So I broke 108 down into 36 times 3. What does the product property tell me I can do with these two things? Separate them under their own radicals. And multiply the radicals. What's the square root of 36?
6.
6. Can I take the square root of 3? Nope. Okay, condition 1. I'm saying this is simplest form, right? Let's double check meeting our conditions. Condition 1, what does condition 1 tell me to do? Or that I can't have happen?
Can't be a radicon.
Very good. So I can't have any factors under my radical that are perfect squares besides 1. I can have 1 under there. What are the factors of 3? What and what? 1 and 3, right? Are any of those perfect squares? No. So condition 1, checked off. Condition 2, I can't have a fraction in the radicand, can I? Do I have a fraction in the radicand here? No. Condition 2, checked off. Condition 3, I can't have a radical in the denominator. Do I have a fraction that has a radical in the denominator? Nope. So is this in simplest form? Yes, it is. Everyone see how we use the product property there? Some people like this a lot because their brains can find that perfect square that goes into that number. If you can do that, great, do it. If not, you may need to start using the factor tree. That's fine too. You're going to get the same answer. So let's look at the factor tree. Can I erase all my work? So can someone raise your hand and give me two numbers that multiplies to give me 108? 12 and 9. Do you think it would have been okay if I picked 36 and 3 first? Yeah, it's going to break down the same no matter what two numbers I pick first. As long as they multiply to give me 108. Okay? Can 12 be broken down into anything? What? 3 and 4. What about 9? 3 times 3. Everyone okay with that? What about 4? 2 and 2. Can my 3s? No, they all just come down. So there's my prime factorization of 108. 2 times 2 times 3 times 3 times 3. What's the index of my radical? 2. So I'm looking for pairs of numbers. 2 of the same thing. Okay? Do I have any pairs here? Pair of what? 2s. Pair of what?
3s.
Any other pairs? No. What do I do if it has a pair? Yeah, I pull it outside the radical, right? So, I'm pulling a 2 outside the radical. What else am I pulling outside the radical? A 3, because the 3 has a pair as well. When I pull 2 things outside of the radical, what do you think I do with those 2 things? Multiply them. If it does not have a pair, where does it have to go? Inside the radical. So what goes under the radical here? 3. Okay, what's 2 times 3? 6. Did I get the same answer I got earlier?
Yes.
Yes, I did. And we already checked our conditions, so I'm not going to go through the conditions again. Raise your hand if you like the first method better, the product property. Finding the biggest perfect square that goes into the number, break it down. Raise your hand if you like this method better, the factor tree. Some of us didn't vote. What does that mean? Okay, let's vote again. Everyone needs to vote here. I want to see what everyone prefers.
What if you like both?
Which one do you like better? That's what I'm asking. Okay, raise your hand if you like the first method better, the product property. Raise your hand if you like this method better, the factor tree. Very good, okay. Then pick which one you want to use each time.
I choose for the first one.
You like the first one better? Okay.
First one.
Can I erase letter A and move to B? Okay. Uh-oh. B has a variable.
Yeah.
Let's do product property first. So what's the biggest perfect square that goes into 9? 3 is not a perfect square. These are my perfect squares up here. What's the biggest perfect square that goes into 9? 9. So do I need to break this down into anything? No, it's already a perfect square. Okay? But I got that x to the third power. What's my index here? 2. So what's my biggest multiple of 2 that is either less than 3 or equal to 3? 2. Does everyone understand that? So, I'm going to break this down into x squared times x. And here, let me show you why I did that. If I'm multiplying something with the same base, what do I do with the exponents? Add them. So there's a 1 here. What's 2 plus 1? 3. So is this still 9x cubed under the radical?
Yes.
Yeah, it is. I kept it equivalent, didn't I? I broke it down like this because I can separate everything into its own radical. What's the square root of 9? Can I take the square root of x squared? Are you sure? What number or variable times itself gives me x squared? There you go. Square root of x squared is x. Another way we can do that, take the square root or any root of a variable, is I can take the exponent under the radical and divide it by your index. What's the index here?
2.
So 2 divided by 2 would give me
1.
1. So x to the first power. Can I take the square root of x? No, I can't. So, whatever your index is, you've got to find the biggest multiple of that index that's either less than or equal to your biggest exponent in here. So this exponent's 3. So I know my biggest multiple of 2 was 2. That's below 3. So I broke it down into x squared times x. Okay? Now, you can use a hybrid of the two methods if you want. If that really confused you for the variables right there, do the product property for the number part, and then for the variable part, break it down. Actually, I haven't showed you this yet. Scratch that. Rewind. Are there any questions about this before I explain what I'm going to do next? Can I erase? Okay, now let's use our factor tree here. What can I break 9 down into? 3 and 3. Can those be broken down any further? No. How many x's do I have if I have x cubed? 3. What's my index of my radical? 2. So I'm still looking for pairs, either pairs of numbers or pairs of variables. Okay? What do I have pairs of here? 3 and x. So what am I pulling out of the radical?
3x.
3 and an x. What stays under the radical? X. Because that last x does not have a pair, does it? Did we get the same answer?
Yes.
Yes. So back to what I was about to say before I rewound myself. You can use a hybrid method if you want. If you like the product property, use it for your numbers. But if the product property confuses you for the variables, do our factor tree method for it. Break it down into x times x times x. Look for how many pairs of x's you have and pull those pairs out of the radical. Does that make sense?
Yes.
Okay, we good with these two examples?
Yes.
Okay, move on.
Yes.
To more examples. Yay! So, on these examples, I'm just going to use the factor tree method, and then I'll talk you through the product property after we look at the factor tree. Okay? That way we still get kind of both methods. Okay, square root of 24. Izzy, what two numbers can I multiply together to get 24? 12 and 2. Could I have picked 6 and 4 if I wanted to?
Yes.
Yeah, could I have picked 8 and 3 if I wanted to?
Yes.
Yeah, it's all going to break down the same. Brandy, what two numbers could I multiply together to get 12? What times what gives me 12?
I don't know. I can't remember. We just did it.
Huh?
We just did it. I can't remember.
Is 12 divisible by 2?
Huh?
Is 12 divisible by 2?
No?
What's 12 divided by 2? Yes, you do. And you got a calculator in front of you.
You're right.
12 divided by 2.
Divided by
12 divided by 2. What does that give me?
6.
Elena, I'm not asking you.
Broken.
Huh?
Broken.
12 divided by 2.
It's broken. It won't let me do it.
Hit on and clear at the same time. So what times 2 gives me 12? What'd you just say? What number? 6. 6 and 2. Can 2 be broken down into anything? No. What about 6?
Yes.
What?
3
3 and 2. Is that all I can break down?
Yes.
Yep, there's my prime factorization of 24. What's my index of my radical? 2. So I'm looking for pairs of numbers.
Please go to sleep.
What do I have pairs of? A pair of 2s. Any other pairs? No. So what am I pulling out of the radical here? Just 1, 2. What stays under the radical? 3 times 2. What's 3 times 2? 6. Does this meet all 3 factors or conditions? Is there a perfect square that goes into 6? No, there's not. None of my perfect squares go into 6. Now, do I have any fractions under the radical? No. Do I have any radicals in the denominator of a fraction? Nope. This is in simplest form. Okay? Okay. Product property. What's the biggest perfect square that goes into 24? What? What are my perfect squares? Is 12 a perfect square? No. What? 4. 4 times what gives me 24? 6. What's the square root of 4? 2. So I get 2 times the square root of 6. Is that the same answer? Yes, it is. Questions on either method on number 1? Perfect. Are we understanding it? Getting the hang of it? Sure. Okay, number 2. What number is understood to be in front of that square root of 80? What? -1. I got that negative sign out there, right? I'm going to have to account for that later on. I'm not going to worry about it right now while I'm doing my prime factorization, but I can't forget about it. I got to bring it back into my final answer. So factor tree of 80. Rennie, what are 2 things that multiply to give me 80? What times what gives me 80? 20 and 4. Everyone agree with that? Once again, I could use any 2 numbers that multiply to give me 80. It's all going to break down the same. Sarah, what can I multiply to get 20? 2 and 10. Holden, what about 4?
2 times 2.
2 and 2. Everyone with me so far? Ryan, what about 10? 5 and 2. Can any of those other 2's be broken down?
No.
No. What is the index of my radical? 2, so I'm looking for pairs of numbers. What do I have a pair of? 2's. What do I have another pair of? Do I have any other pairs? No. So what am I pulling outside of the radical here? 2 and 2 2's, right? But don't forget about this -1 we have out front. I can't forget about it. So I have that -1 first. I pull out a 2 for the first pair of 2's. Pull out another 2 for the second pair of 2's. Does anything stay under the radical?
Yes.
Yeah, what? If it doesn't have a pair, it's got to stay. 5 doesn't have a pair, so it's got to stay under the radical. What's -1 times 2 times 2? -4 square root of 5. We okay with that? Okay, product property. What's the biggest perfect square that goes into 80? Huh? 9 doesn't go into 80.
4.
4 goes into 80. 4 times what will give me 80? 20. Is there another perfect square that goes into 20? What? 4. So is 4 the biggest perfect square? No. 16. Very good. 16 times what will give me 80? 5. 16 times 5 will give me 80. Okay, are there any perfect squares that go into 5? No. So 16 would be the biggest perfect square. What's the square root of 16? 4. I'd multiply that 4 by -1. I'd get -4 square root of 5. Is that the same answer? Yes, it is. Questions on either method there? Perfect. We're killing it, aren't we? How we feel about it? Good. A lot of examples help, right? Number 3. What times what would give me 49? 7 times 7. Can those 7s be broken down more? No. How many x's do I have? 3. So there's my prime factorization. That was pretty easy. What's the index of my radical? What's the index of my radical? What's the index of my radical? 2. Remember, if there's no number in the index position, it's understood to be 2. Make sure we hear the question and what I'm asking before we throw out an answer, okay? I know I can be sometimes predictable, but sometimes I can be unpredictable. You gotta be on your toes. You gotta be ready. So what's my index here? 2. So I'm looking for pairs of numbers. What do I have pairs of? 7s and x. Any other pairs? No. Am I moving too fast for anybody? So what am I pulling outside of the radical? X and 7. It's got a pair, I pull it out. 7's got a pair, I got to pull a 7 out. X has a pair, I got to pull an X out. Are there any other pairs that I'm pulling out? Is there anything left under the radical? X. That last X doesn't have a pair. If it doesn't have a pair, it's got to stay. Questions there? We good still?
Yes.
Can I erase and move to number 4?
Yes.
Perfect. All right. What times what will give me 75?
3.
Yeah, 25 and 3. You can think of quarters there. 3 quarters gives me 75 cents, right? Can I break 25 down anymore? 5 and 5. What about 3? No. What about my 5s? Nope. There's the prime factorization of 75. How many n's do I have? 1, 2, 3, 4, 5. 5 n's. What is the index of my radical? 2. So I'm still looking for pairs of numbers or variables. So what do I have a pair of? A pair of 5s. Any other pairs? N's. Any other pairs? N's again. Any other pairs? No. So what all am I pulling out here?
5.
A 5, an N, another N, anything else? No. Is there anything staying under the radical? 3 N. 3 doesn't have a pair. This last N doesn't have a pair, so they got to stay. Oh gosh. Yeah. Okay, what's 5 times n times n? What? Yeah. Remember, when we're multiplying something with the same base, what do we do with the exponents?
Add.
So what's 1 plus 1? 2. So I'd get 5n squared times the square root of 3n. Questions there? If I was using product property, what's the biggest perfect square that goes into 75? 25. Make sure we know what the perfect squares are. You may want to have a list of them at the top of your paper if you're using the product property. So I'd break this down into 25 times 3 times, what's the biggest multiple of 2 that's less than or equal to 5? 4. So I'd break this down into n to the 4th times n. Does everyone see that? Can I take the square root of 25? What is it? 5, right? Can I take the square root of 3? No. Can I take the square root of n to the 4th? Yeah? Remember our little trick I used earlier? I can take this exponent and divide it by the index. What's 4 divided by 2? What? So I get n squared. Can I take the square root of n? There you go. Everyone see that? Any questions there? Or like I said, if you wanted to, you could use the product property for your numbers. So square root of 25 times 3. I know that would be 5 square root of 3. And if you wanted to, you could use your factor tree for your variables. Got a pair of n's there, pair of n's there. I know I got to pull out 2 n's, so n squared would be with the 5. This n would have to stand as a radical with the 3. You could use a hybrid method. Okay? Any questions on 4? Can I move on? 2 more examples. Just kidding. Page 297, numbers 5 through 20, y'all. Get it written down so I can kind of go over it with you on the board and talk you through the assignment. Are there any questions that would pertain to my recording before I end it?